Hi guys, my name is Melissa, and so in today's video we're going to be talking about a strategy called solve by assuming. And so for today's video we have a lot of practice problems, and so we're not going to go over all of them. And so we're going to go over some important practice problems, and I'll leave other problems so that you can solve on your own. And so problems introduced are most commonly solved using tables. And so we're going to try to attempt to solve these problems by asking if all were. And so we're going to assume to solve. So for example, it says, a farmer has 36 chickens and rabbits. There are 96 legs altogether. How many chickens does the farmer have, and how many rabbits does the farmer have? And so chickens have 2 legs each, and rabbits have 4 legs each. And so we have 2 methods. So the first method is going to assume that all are chickens, and the second method is going to be to assume that all are rabbits. So you guys should choose one method. So I'm just going to say that all are chickens. So if all are chickens, then we have 36 animals in total. And so the total, if all of the 36 animals are chickens, then it's going to be 36 times 2, which is equal to 72 legs. But then it says we have 96 legs altogether. And the difference in legs between rabbits and chickens are going to be 4 minus 2, which is 2 legs. And so 96 minus 72 is going to be 24. And so we have 24 legs that we need more. And so the difference in the number of legs between a chicken and a rabbit is 2. And so if we do 24 divided by 2, we get 12. And if we have 24, so we have 24 divided by 12, which tells us that we have 12 rabbits. Now, based on this information, we're going to go back to the first information that we had 36 chickens and rabbits in total. So that tells us that we have 36 minus 12 chickens, which is going to be 24 chickens. That is one way to solve this problem by assuming. Another way is just thinking that all are rabbits and doing the same type of calculations, but then now we're going to have 48 divided, we're going to get the same answer, but it's just that we start with the rabbits first. Now we're going to move on to the next page. So it says a cashier collected $312 from the sale of 50 tickets. An adult ticket cost $8 and a child ticket cost $4. How many tickets of each type did the cashier sell? Again, we can choose to assume that either all tickets sold were adults, or assume that all tickets sold were children's tickets. So I'm going to assume that all were adult tickets, which is the first method. If you guys choose to assume that all were child tickets, then you can look at this. But I'm going to explain in terms of thinking that, in terms of assuming that all tickets were adult tickets. So assuming that all 50 tickets were adult tickets, we say that since each adult ticket is $8, we must have earned $400. But then the difference from that and 312, which is what we actually earned, is going to be $88. So we have an extra $88. And the difference between an adult ticket and a child ticket is $4. And so we're going to divide the difference after assuming and difference in actual ticket, and that is going to give us 22. And so that tells us we have 22 child tickets. And if we know this information, we can find the number of adult tickets that were sold, because in total we sold 50 tickets. So we must have sold 50 minus 22 adult tickets, which would be 38 adult tickets. Well, 28 adult tickets. Now let's look at example 3. It says there are 30 questions in a math competition. 5 points are awarded for each correct answer and 2 points are deducted for each incorrect answer. If Colin scores 122 points for the math competition, how many incorrect answers does he give? So first of all, I'm just going to assume that Colin got everything correct. And so if he got everything correct, we have 30 questions and 5 points awarded. So he must have earned 150, assuming everything was correct. But then he only got 120 points in reality. So the difference is going to be 28 points. And the difference between getting a correct answer and getting an incorrect answer is going to be 7. So I know some of you guys might think, oh, isn't the difference 3? But if you look carefully, 5 points are awarded, so it's a positive 5. But then 2 points are going to be deducted, so it's a negative 2. And since we're looking for a difference, we're going to subtract those. So double negative is going to be 5 plus 2, which is going to give us 7. So you guys should really pay attention to those details. So we're going to divide the difference by the difference in points. So that's going to be 4. And so that tells us that he had 4 incorrect answers. And since he answered 30 questions in total, that tells us that he solved 30 minus 4, which is 26 correct answers. Now let's look at example 4 together. So 5 similar basketballs and 6 similar volleyballs cost $325. A basketball costs $10 more than a volleyball. So we're going to say that we're going to assume that everything was, we're going to assume that all were basketballs. So if you guys are going to assume that all were volleyballs, you should look for method 2. But I'm going to explain in terms of assuming that all were basketballs. So if all were basketballs, 5 similar basketballs and 6 similar volleyballs cost $325, and a basketball costs $10 more than a volleyball. And so we have 325 plus 6 times 10. And that gives us 325 plus 60, which is equal to 385. And the reason why we did 6 times 10 is because assuming that everything is a basketball costs $10 more. And so we're going to assume that for the volleyballs, which we had 6, we're just going to count that as the same price as a basketball. And then so if all were basketballs, the price would have been $385. but then we have 11 in total. So we're going to divide, and that gives us $35. So each basketball would have been $35. Now, if you assumed that all were volleyballs, you would have subtracted 5 times 10. You would have subtracted 50 because basketballs are $10 more expensive than a volleyball. So if we assume that basketballs are volleyballs, then they would cost $10 less than it actually is. So we're going to look at example 5. So it says, Mr. Brandon has 58 $2, $5, and $10 bills all together. The total value of these bills is $322, and the number of $2 and $10 bills is the same. How many bills of different denominations does he have? So if we assume that all are $6 bills, so the first method is creating a new denomination, which is a $6 bill. But I personally think that that would be a little more complicated because it might be hard to think of an imaginary bill. So let's look at method 2. We're going to assume that all are $5 bills. If all are $5 bills, he has 58 bills altogether. So the total amount that he has monetarily will be 58 times 5, which is $290. Then he actually has $322. So the difference is going to be $32 difference, calculated and actual. And then the difference in the total value of all bills is $32. Now we still have to use an imaginary bill called $6, and the $6 came from an average of $10 and $2. But then this uses $6 in a more easier way, so I prefer method 2. So the difference is $6 minus 5, which is going to be $1. And so 32 divided by 1 is going to be 32. So that tells us we have 32 $2 and $10 bills. And so that tells us that the remaining 58 minus 32, which is 26 bills, is going to be $5 bills. Now, since we have the same amount of $2 and $10 bills, that tells us that we have 16 of each. So in total, we have 16 $2 bills, 16 $10 bills, and 26 $5 bills. So now we're going to solve some practice problems. And so to solve the first problem, which is similar to the first practice problem that we solved, I'll be giving you guys about 3 minutes to try to solve the problem, and then we'll go over the solution together. And so I'll go over the first problem. So it says a farmer has 45 chickens and rabbits. There are 140 legs altogether. So I'm going to assume that all 45 animals are going to be chickens. Then since chickens have 2 legs each, that's going to be 90 legs. But actually we have 140 legs, so the difference is going to be 50 legs. And the difference in legs between a chicken and a rabbit is going to be 2 legs difference. So 50 divided by 2 is going to give us the number of rabbits we have, so we're going to have 25 rabbits. Then knowing that in total we have 45 animals in total, we're going to have 45 minus 25, or 20 chickens. So we have 25 rabbits and 20 chickens. And you can solve problem 2 using a really similar strategy. So now we're going to move on to the next page. So in problem 3, Andy spent $55 in all to purchase $22 and $5 toys. How many $2 toys did he buy, and how many $5 toys did he buy? So for this problem, I'll also be giving you guys about 3 to 4 minutes to try solving this problem on your own before I start going over the explanation and solution. And so for this problem, a hint that I would give is you can choose either to assume that all of the 20 toys that he bought were all $2, or all of the toys that he bought were all $5. And you should start by choosing which one you want to assume happened, and then start solving the problem. So I'll be giving you guys about 3 minutes from now, and then go over the solution together. And so we can assume that all of the 20 toys that he bought were $2. If all of them were $2, then that would give us $40, but we spent $55. So that would be a difference of 15. And the difference in cost of each toy is going to be $3 because it's 5 minus 2. So we know that 15 divided by 3 is going to be the number of $5 toys. And so that's going to be 5 $5 toys. And so since we know that we had 5 $5 toys, we're going to have 20 minus 5 $2 toys, so we're going to have 15 $2 toys. So we have 5 $5 toys and 15 $2 toys. Now again, you can solve the next problem using a similar strategy. And so for problem number 5, it says, an adult ticket to a concert costs $35 and a food ticket costs $18. So again, I want you guys to try solving this problem before looking at the solutions and explanation with me. So I'll give you guys about 3 to 4 minutes to solve this problem on your own. And again, a hint that I can give you guys is you can choose to assume that all of the tickets he bought were for food, or either all of the tickets he bought were for the adult tickets. And so you can choose one scenario and then solve based on that. But whichever scenario you choose, you will get the same answer. It just depends on which calculation you think is going to be easier. And so, yeah, I'll see you guys in 3 minutes. And he paid $598 for 20 such tickets. So if we assume that all tickets were adult tickets, then that would have been 20 times 35, which is equal to $700. But in reality, he only spent $598, so the difference would be $102. And the difference in the ticket is going to be 35 minus 18, which is going to be $17 difference. So we know that 102 divided by 17 is going to be the number of food tickets. And so 102 divided by 17 is going to give us 6. So he bought 6 food tickets. And in total, he bought 20 tickets. So we know that he bought 20 minus 6, or 14 adult tickets. Now, problem number 6, you can solve in a similar way. And so next it says, a science quiz consists of 15 questions. 2 points are awarded for every correct answer, and 1 point is deducted for every wrong answer. Kelly scores a total of 21 points. And so how many questions does she answer correctly? Now I'll be giving you guys 3 minutes to solve this question on your own as well before we go over the solution. And one thing that I want to warn you guys is similar to the practice problem that we solved earlier, the example problem that was similar, for this, to figure out the difference between the number of points awarded for the correct answer and incorrect answer, we're awarding 2 points when the answer is correct, but then we're deducting every wrong answer. So for example, the difference between the points awarded for the correct and incorrect answer in this case would not be just 2 minus 1 equals 1, but instead it's going to be 2 minus, so since we're finding the difference, it's going to be 2 minus parentheses minus 1 because we're deducting a point for every wrong answer. So in reality, the difference in points awarded for a wrong and incorrect and correct answer is going to be 3 points. So that is a hint that I would give you, and I'll see you guys in about 2 minutes. So if there's 15 questions, let's assume that all of them were correct. If all were correct, she would have earned 30 points. But she only earned 21 points. So the difference in our calculated assumed value and what she actually got is going to be 9 points. And the difference in number of points she gets when she's correct or incorrect is going to be 3 points. And that's because she is awarded 2 points when she's correct, but then she's deducted 1 point. So again, that's going to be 2 plus 1 difference, since we're taking away 1 and giving 2. So the difference is going to be 3 points. So we know that it's 9 divided by 3. So we know that she got 3 incorrect answers. And since we have 15 questions total, we must have 15 minus 3, or 12 correct answers. Now problem 8 is a similar type of question, so you can solve that using a similar strategy. And so we're going to look at problem 9. So it says, a math quiz consists of 30 questions. The first 20 questions are worth 4 points each, and the last 10 questions are worth 7 points each. And so this is actually a similar type of question to what we did. So it's basically awarding points and answering questions, but this problem is a little trickier because now we're worth 4 points each. But then for the last 10 questions, it's worth 7 points, so it changes. But then you guys can divide these into 3 sections. Well, you guys can divide it into 2 sections. So you can divide it to when it was worth 4 points each, and another section to where it was 7 points each. But generally, the basic idea is the same. So I think you guys can solve this problem using a similar strategy. And for problem 10, Mr. George spent $375 in all for 5 similar tables and 6 similar chairs. Each table cost $20 more than each chair. So each table cost $20 more than each chair. So if we assume that all were chairs, well, all were tables, I guess, we're going to have 375 plus each table cost $20 more than each chair. So each chair is going to be represented as $20 more expensive. So we need to do 6 times 20. So that is going to be 495. Then we have $495, but he actually spent $375 only. So the difference is going to be 120. And so we know that for chairs, each chair must have been $20. So since a table is $40 more expensive, a chair is $20, and a table must have been $40. And so this problem is what we solved here. And so a basketball cost $10 more. Oh, sorry. So for here, sorry, I made a mistake. So in total, we spent $495. But then the difference, if you look at this problem, the way we solved it was, it says the total, we found the total price, and then we looked at the sum. And so instead of comparing it to how much he actually spent, we're going to say the total was $495, 4, 5 plus 6 items. So 495 divided by 11 is going to be 45. And so a table must have been $45. And since each table is $20 more expensive, each chair was probably $25. And so if we test that out to make sure we got it correct, 45 times 5 is equal to 225. And if we add that to 5 times 25, that gives us a total of, so we have 45 times 5, which is 225. Then we have 25 times 6. That gives us a total of $375, which is how much he spent in total. And so that is it for our lesson today, and I'll see you guys all in the next video.